So hello everybody, welcome back to the stream. So we were learning recursion. Um, so let us continue with recursion and see what more we can learn in recursion. So let us see. All right. So here yesterday um, we did the program to find the factorial of a number and what was this one? Okay, this is a basic program that includes recursion. All right. Um, okay, so here there is a program to, okay, so Fibonacci with recursion. All right. So that is there. All right. Let me just, okay. If you're here, just let me know. I hope the audio is fine. Um, all right, I hope the audio is clear. If you are here, please let me know. Just drop a hi. And let us just continue with our learning. All right, so here, so here we are required to print the Fibonacci sequence, right? Um, all right, so let us see how we can do that. Okay, so here I think, so first you need to know what is Fibonacci, right? Fibonacci series. So if you look at it here, or if you just Google Fibonacci series. So it's just a sequence of numbers where each number is the sum of two preceding ones, starting from 0 and 1. So here, if you see, starts from 0 and 1, right? And then the next number is 0 plus 1, and then the number after that is 1 plus 1, 2. And then if you see here, you have 2 plus 1, 3. 3 plus 2, 5, 5 plus 3, 8, and it keeps going like that. So those are the Fibonacci numbers. All right. So there is a ratio here that's given. All right. So those are the Fibonacci series. Um, if you look at it here, as you can see, this series is printed. Fibonacci were five numbers for five numbers. So that is printed over here. All right. So here, let's see how we can do that. Um, First of all, let us just see the edge cases. That is when we should stop, right? We need to stop when n equal to 0, right? And also when n is in this, right? 1 or 2, right? N is 1 or 2, we don't need that. Similar to the previous thing that we did, right? Over here, there is a base case, right? For the factorial, similar to that. So for that, it was 0 or 1. And here we have 1 or 2. And then else, here, this is the case of the recursive function. Fibonacci, this is a function, again calling itself, right? So, okay, n minus 1 and then n minus 2. So that is the series, right? Over here, if you see, this is how it goes, right? The sequence n minus 1 plus n minus 2. So that is what is here. Um, so, like, as you can see for factorial, it is n into n minus 1, right? Here it is just n minus 1 plus n minus 2. So that is the Fibonacci series. And here you have just given the n value, um, and your for loop for printing the series, right? It just goes and just prints the series, and the function is called over here, right? And just prints n amount of times, right? I less than n over here is said. So yeah, that prints this output. So let us see how we can do this. I think we need, okay, so let's see if we do need that or not. So I'm just going to, let me just comment this out. Okay, so let me just create Fibonacci series, and let me keep it as func, or let's keep it as Fibonacci fib, and yeah, int n, let it be that way. Base case, let us change this base case to 1 or 2. So those are the cases we do not, or is it, yeah, it's 1 or 2. And also for, there is another stop case here, which is n equal to 0, n equal to 0, right? And you would just return 0 here, and the recursive case would just be recursive case. If you store it in a result variable, okay, we don't need that. Let us not store it in a result variable. Let us just say, um, how do we do that? Okay. I'm just gonna say fib n minus 1 plus fib n minus 2, which is the series basically. And what do we do here? Okay, we just return I'm not storing it in any variable. I'm just going to return this directly. Return, return this. All right. Let me just put this in a bracket as well. Just makes it more clearer. All right. I think that's good enough. Okay. Now I need to call this recursive function. So let me just go ahead and okay. Do we have to get the input from the user n or should we define it over here? Okay, let's just define it here itself. I'm just going to say um int okay, so we should get C out, right? C out. Okay, n equal to 5, we are just saying first. And n equal to 5, and then just C out, C out, whatever. What is that? We have to see out. Just see out. Um, Fibonacci series. Okay. Let's just say Fibonacci series of 5 numbers. Okay. And we'll end it there. And now I'm going to have a for loop because we need to loop it, right? I equal to is it n I equal to 0 starts from 0, okay, and I less than n, and you have I plus plus, just increment I inside the for loop. I'm just going to put this in there. All right, I think I can just put it here, right? I change this to fib 5, or fib n, right? Fib n, I guess, or is it fib I? It's fib I, right? Fib I, fib I. We have to loop it I times, right? So fib I, and here let me just define uh all right. So int I equal to 0, and okay, so that's done. So let me just I was okay, that's not required. We are already using handle. Okay, so let me just save it and run and see if we are good. Okay. All right. So we got the series here. Okay. This here instead of handle, if I just did this, I think that would be sorted. Yeah. So now we got it correctly. Fibonacci series of 5 numbers. Yeah, that is correct. And if we want to change it to maybe and seven numbers, then again, if we run, so yeah, we got up till 8, so that is correct. Now, how can I get the input from the user and then print it? Now I want to get the input from the user, that is the n. So let me just do that. I'm going to ask for input here. So I'm just going to say cout enter, cout enter n, enter n, and I will ask for the input cn, cnn. All right, so then this is not required. So I'm just asking for the input here. So let me also initialize int n here. Now, okay. Now I'm getting the input from the user, the number of times or the total numbers. So let's see if we are able to do that. So now it is asking for the input n. So let me just say, for example, 10. Yeah, now it printed for here. Now it is saying 5 numbers, so that we just have to change that. Simply just say Fibonacci series of, and then close it here, right? And then I'm just going to say n, and then just say numbers. All right, that's it. Now if I run again, now let's see. Now I'm going to say 10. So now you can see it is printed more better and in a readable way. If I want it to be even more good, then I have to have the space as well there. So 10, yeah, now it is correct. So Fibonacci series for 10 numbers, if I change, for example, let us just rerun it and see if I get it for example, 13 numbers. See, for Fibonacci series for 13 numbers, now we are getting it. So that was the Fibonacci series. Yeah, that is it, I think. Yeah, that's pretty much it. So common applications of recursion used for systematically exploring nodes and vertices. Okay, that we can see when we come across these data structures. So sorting algorithms, these is use quick sort, merge sort, divide data into subarrays, sort them recursively and merge them, divide and conquer algorithms, um, binary search, okay. Then you have fractal generation, um, all right, okay. Um, Backtracking. So backtracking is I think is the most used when it comes to recursion, memoization as well. So caching of results of a recursive function. Um, so yeah, it is quite extensively used. So yeah, there is all the examples that's given here. All right. So there are some practice problems. We'll look at that later. Let us see what we have here. Okay. So if you are in the chat, let me know. Let me check the live chat. Okay. Please let me know. If you have any questions also, please do ask. Uh, all right. Here also it is the same thing. Factorial of a number. We have done all these, right? Um, okay, here is just the sum. Okay, so that was about recursion, I guess, pretty much it. Let us see what else we can learn. Recursion. Okay, there is a Reddit over here. I'm not a fan of like Reddit for like you know, not a fan in general when it comes to trusted source, but it's fun to read. So let's see what is there over here. Uh, so somewhat like a loop. Okay. Okay, all right. Uh, so yeah, all right. Recursion is defined here. Recursion is when a function. Okay, I don't know what that is. Okay. All right, all right, all right. Got it, got it, got it. Uh, have been reading about recursion. Okay. Sometimes on Reddit you get really good intellectual stuff. Sometimes it's just garbage, but yeah, that's how it is. Um, okay. There is always a base case. Okay, right. Okay, so yeah, all right, all right. What else do we have here? Okay. All right, so this thing I explained like how the stack works yesterday. So if you want, you can check out yesterday's live stream. Um, okay, Fibonacci numbers, that's what we did right now. All right, so not much, I guess. Um, all right. We can see Fibonacci sequence, mentioned a lot here. Okay, it's not a loop. A loop is infinitely the same recursion is effectively the same process with, but each time you address a new aspect of the same problem. Imagine it like a spiral where each cycle is the same motion, but every revolution gets closer to the truth. All right, so that is pretty much it, I guess. I don't think there is anything else. There is a famous lead code problem as well. Um, yeah, I think that is pretty much it about recursion. We have. Okay. Yeah, I think that is good enough. I guess that is probably good enough. So let's see what is the next thing. We have lambda functions. Okay, we have lambda functions next. Okay, all right. So this is something we have to look at. Let's see. All right, we will see this tomorrow. Let's not do everything today. Um, After that, let's not do classes. Let's do classes and everything later. Errors, maybe we can do that. And then we'll go with data structures and reference, maybe this. Let's see what we can do next. Yeah, I think today we'll just keep it short. I just wanted to complete with recursion. So yeah, let's wind up for today. Yep. So I hope you enjoyed watching this live stream. And if you did, please do like the video, and share it with your friends who might also be interested in watching these kind of streams. And yeah, subscribe for more such live streams. And until the next one.